I will go over how to solve and deal with these type of rate problem. So the first few questions is trying to ask how identify the order of reactant A, B, and C, and also overall order of the reaction. So let's do that first. So how do you do that is that by viewing this chart right here. So let's compare C first. Okay. So when we take a look at this chart right here, so when we have the same concentration of A and concentration of B, right? When we increase, decrease, let's compare 1 and 4. When we decrease the concentration of C by half, the initial rate doesn't change. It's still 11.2. So meaning that in this rate, within this rate law, C is not considered. It is a zero order reaction. So that's just don't consider C. And we can know that the order of C here is zero order reactant. Okay, so that's deal with A and B. So let's compare 1 and 4 first. 1 and 2 first. So when the B stays constant, when we increase A by two times the concentration, that's compare experiment 1 and 2. So when we increase twice the initial concentration, we can see that the initial rate has doubled. So meaning that if we have twice y as an exponent, we get 2. So y equals 1, meaning that this reaction A is a first order reaction. Let's compare another one. So right now let's compare as A stays constant. Let's compare experiment 2 and experiment 3. So when we doubling up the concentration of B, we got 4 times of initial rate, meaning that if we double it, double it amount of B, we got 4 times the rate, meaning that 2 to the x power will equals 4 and x will be equals to 2, meaning that the second reaction, meaning that the reactant B is a second order reaction. Okay, so this is how you deal with the order of the reactant A, B, and C respectively. So now we're going to deal with what is the overall order of the reaction. So for this, we just add up the 3. So let's write the overall out first. So the rate will equals to the rate constant times concentration A with one power to the first power, and concentration B to the second power. And this is how the overall rate equation will be. So what is the overall order of the reaction? So we just add up the exponents right there. So we have total of 3 exponential 1 plus 2 equal 3. So the overall order of this reaction is 3. Okay, and we already answered this already. So the rate will equals to K times A and concentration B squared. Okay, so the next question tells us to calculate the rate constant K and identify its units. So let's do that. So we just continue write things here. So if we want to calculate k, we know that k will be equals to the rate divided by a times b squared. And we can just like select either of the row to do the calculation, and I choose the first one, which is experiment 1, the data from experiment 1. So the rate is 11.2, and the concentration of A at that point is 14. Concentration of B is 200, and we need to square because it is a second order reaction. And the K after calculation will be 2 times 10 to the negative 5 power millimole per liter. And this is what it is here for K. So it is 2 times 10 to the negative 5. Okay, so right now we're calculating the units for a rate constant. So how do we do that is we know that the K, like the K value, the unit of K is millimole divided by liter per second, and we can know that is because that the initial rate that's a given a unit right here. And we know that based on this equation up here, we know that the K times the unit millimole, like this entire thing is the unit of concentration, which is millimole per liter, and this is for the concentration A, and the unit of concentration B is millimole per liter. However, we need double it. And after putting these all together, we have liter squared, liter cubed times millimole times liter times second times millimole to the third power. And after leaving it, this is L squared, and we know that the unit of that is liter squared times millimole negative 2 power and second negative 1 power. So that is the answer for like the question right here. So we get that the unit of that is square the third one. Okay, so for the last question, we wanted to calculate the initial rate of the reaction when the concentration of A, B, C is given. So how do we do that? Is just plug in the numbers. So we know that the rate of initial equals K times A times concentration of B squared. We know K value is 2 times 10 to the negative 5, and A equals 4.06, B equals 0.149 squared, and we got 1.8027 times 10 to the negative 6 milliliters per second. And this is this is the initial rate. So this is 1.8027 times 10 to the negative 6, and this is how you solve for this question.